Shop. I'm going to do kind of a follow-up on the piston for the 1928 Franklin. Kind of sneak back here. Alright, here's the piston. It's all finished, it's all welded up, and I got to look. I was looking on the inside, and I found some lettering under the black carbon oil soot. And what I found is it said Levett Company, New York. So I guess Levett maybe made pistons, obviously, back in the day. And then on the other side, it said Mag Al LE Pat 3418. So I'm assuming that means magnesium, aluminum. LE Pat would probably mean Levett patent. And then 3/4 of 18, thinking 1918, if this was a 1928 Franklin. But I thought it was just really cool that I found that under the piston. So I'm going to go, when I go in the house, Google Levett Piston Company, New York State, just to see, you know. It's one of the things that really I like about old stuff is they're all artifacts, you know. They all tell a story. And these Franklin engines are really like aircraft engines because they're air-cooled. But, you guys know I'm from Buffalo, New York, so I'm real proud of New York State and all the business and industry and innovations that happened in New York State. So anyhow, so I thought I'd share that with you guys. Let me draw out one of my lessons learned here. So I'm doing a section of the piston. So here's the top, and it comes down. Here's the first compression ring, the second compression ring, the scraper ring, and the oil ring. You know, kind of a quarter section, whatever. So what was damaged on this piston was this in here. Was all, you know, it was all gnarled up. Come on, there you go. So this was all gnarled up. So these are the ring grooves, and I call this the lands of the piston. The lands is where the ring bears upon. So what I wanted to do originally is to get this all welded in. I removed this on the lathe so I could, you know, weld in that easier with the TIG. And the deal was that I had to fill all this in well. This area here was so thin that I had a hard time. I just burned the land away because it was so thin, as opposed to a nice thick land. So what I ended up doing is I went in the lathe and I cut back some more, and I now had all that to fill in, which I did. And one of the things that I didn't think about, because I was so concentrating on filling in the gap and not burning the land. You know, I filled all this in with weld. But what I didn't realize, and I still had to be careful not to burn, you know, burn back this whole, get my weld in here and burn that back. But I forgot I didn't have to do that. What I could have done is here's the remnant of the land that I cut off on the lathe. I could have just welded, you know, up to there. Redraw some of this. could have just welded up to there, you know, and not butted up against that land, and I just wasn't thinking about it. So some of the, you know, so I left the ring, you know, I left the piston ring. My marker's failing, or my artistry skills are done. I left the ring in that groove right there. So if I did burn into here, I'd have that, you know, piston ring, which is steel obviously, or iron, or whatever it is, to back up the heat. And I touched it a little bit. I know you guys, you probably can't see. Just a little bit. And it's not bad. I mean, you know, it's certainly, it's just a minor, you know, where I just, the metal, the aluminum melted into the ring and just kind of left a little divot. But, you know, it's not bad. The only thing is I'm kind of kicking myself is, you know, I didn't think of it, that I didn't have to, you know, to weld all the way into here. It's kind of what happened is I got penetration all in here. And, you know, even though I had the piston ring in here, I kind of got right into that edge and I melted that just a small amount. But just so minimally, you know, it's not going to matter. But I'm hard on myself for not seeing the fact that, you know, I didn't have to touch that edge. I could have stayed back and not had to worry about that. But no problem. It came out well. I just didn't see it. Okay, so so there's that. The other thing I learned is I was using on the TIG. This is an inverter TIG, so you don't have to ball your tungsten. The tungsten will stay pointed, okay, with this inverter TIG. And why I like that is because you can control the heat more precisely with the pointed tungsten. So what I mean is, you know, on a regular, use pure tungsten, right? And then what ends up happening is it balls up on the end, and then your arc, electricity, energy, kind of goes in all directions. But with the inverter TIG, can't draw this. Just, you know, picture a point. All right, and I'm gonna, you know, all right, perfect. You know, so it really directs the energy of the arc into the puddle. So I was using a 3/32, right? 093. Electrode, and it was too small, and it was getting too hot, and it was balling up. I should have switched to a 1/8 tungsten, and it would have stayed more pointed, and I would have gotten better control of where I was aiming the heat. But it worked. But, you know, next time I weld aluminum, I might step up to the bigger electrode if I notice that it's starting to ball up on me. Like I say, transformer TIGs, you know, the instructions or the training books say to ball it on purpose. But it's so hard to weld with the arc energy going everywhere. With the inverter TIG, one of the reasons I bought it is all the AC waveform balance controls, and it will maintain a pointed tungsten on AC for aluminum. But apparently you have to, you know, step up the diameter of the tungsten electrode. And it's a water-cooled torque. It's a It's an air-cooled torch. If it had been water-cooled, perhaps it would have, you know, been okay and not balled up. But anyways, those are just some of the things I learned. That's why I say it's not perfect, but it's pretty darn good. I'd give it a, you know, like a 90 or 95 out of 100 points, just because I'm a little hard on myself. But that's the thing. Learn when you do stuff. Never be afraid to try. You always learn something, especially in machine shop, engineering. You always learn something. If you're smart, you'll always kind of go back and do a retrospective analysis like I'm doing. I just kind of thought about this and what would have made it easier. But that's my friend Jonathan, his videos, you know, he always says in his videos, well, no problem, you know, this might be a little off kilter, or this might be a little, you know, not as good as I wanted it to be, but no problem. We'll go with it. We'll see if it works. If not, we'll do it over. And that's a great message. Let's just try it. It's no problem. My dad always used to say, when everybody's standing around trying to figure out what to do, he'd say, do something, even if it's wrong. And, you know, if you think about it, you can talk about it till the cows come home and analyze it to death, or you can try something and see what works. And if it's not life critical, if it's not going to be a bridge failure or a building collapse, just try it. Everybody today, they're so afraid to try anything. You know, they want to research everything on their cell phone and all this and prepare, and which is good. But they're stuck in that mode. They don't want to see what happens. You just got to do a cost-benefit analysis and say, what's the worst that could happen? You know, is it going to blow up or explode? Well, you know, keep a fire extinguisher handy. I guess. No, seriously, you got to be safe about things. But yeah, just try it. Get out there and try it. And you know, buy a machine. You know, I don't know if my machines are in the frame. Buy a set of torches. You know, get a lathe. I started on a lathe. Got a mill. Now I'm into grinders. Got a planer. Awesome. Love it. It's just it's a learning experience. The more tools you have, the more you can learn how to use them. The more projects you can tackle. So anyways, I just wanted to share that with you. Until next time, signing off, this is Doozer Shop.